Hello and welcome to the walkthrough of the outer join examples from the book. I want to stress that, reading about outer joins and hearing me talk about what they are conceptually doesn't always help for everybody. Some people get it, but for me, and I know a lot of students, when you're learning SQL, you got to learn by doing. Not everybody, but I think a lot of us it makes sense to do it. So that's where we're going to jump in today and actually go in and mess with some outer joins. So before I do run this query, I can run it really quickly just to see what we're going to get back. And sure enough, yeah, we're going to get some data back and all that. But before we make sense of all this, let's just do something really simple. Let's just change this to a basic inner join. By the time you've gotten to outer joins, we assume you've gone through inner joins and you understand what they are and you've messed with them before. And you'll see here that we get, vendors. Every vendor has an invoice number and every invoice has a total. Now, if I go in and start playing with this, and this is what I recommend when I start using left joins, right joins, outer joins. I'll write my inner join first, and then I'll do a left. I'll just change one piece to left join. So I'll just change it to left join and see what I get back. Then I'll even change it to right join. Even though we know we're not going to use right joins, I'll change it to right join, see what I get. And this right join actually looks just like the inner join. In fact, if I go and look, it's 115 records. Sure enough, it looks the same. That's a pop quiz for you to figure out why does the inner and the right join actually return the same thing. And then I could even do full outer join, and I could run that, and that looks, let's see, it's a 203 rows. And if I change it back to left, just first off, just get used to running it. And actually, it's another 203 rows. So another pop quiz for you would be to figure out, well, why do I have, why does my left join return the same as the full outer? And if you kind of go back to your Venn diagrams, you should be able to kind of know that. And if also knowing what kind of data is in these tables. So what we're doing here in this is that we are taking the left join is telling, we're telling SQL, let me just write this in all caps. You don't have to, but I like to. What we're doing here is we're saying, give me every record on the vendors table. And regardless if that vendor has an invoice, because the invoice is tied to the vendor table through the vendor ID. So it says, give me every vendor, regardless if there's an invoice, but also give me, so that means the vendors that do have invoices, but also the vendors that do have invoices. So kind of the intersection of those two circles, and also the stuff that's to the left of it, meaning that there is no intersection. And so if you'll notice, right, don't get hung up on syntax, because the syntax is really not that different. It's still the same. It's from table, join table on whatever key. The only difference is we're changing it to left. So the hardest part about joins is just understanding what that left does. And what we see here is that it's every vendor. In fact, I'm going to even just pull back I'm going to go and do this. I'm going to grab the vendor ID. I'm going to pull that in and run it. All right, so you'll see here of every vendor. And we can even, let's sort this by vendor ID so that we can know. Sure enough, look at it there. So we have vendor 1, 2, 3, 4, 5, 6, 7, 8. So every vendor, the vendor's name, and regardless if there was an invoice for it. And so you'll notice these are all null. That seems like, maybe that seems weird, but oh, here we go. Here's IBM. They are a vendor and they do have 2 invoices. So what you see here is that it pulled every vendor, and regardless if they had a vendor invoice on their side. In this scenario, IBM got pulled twice because they actually have 2 matching rows on the right side, the invoice table. And if you want, you can go and look at, let's go and look at our tables. So let's select star from vendors. And sure enough, if I scroll down, there's US Postal Service. You get really familiar with this data once you play with it enough. And there's 34, there's IBM. Let me go look at invoices really quickly. And I'm going to sort by vendor ID. I'm going to explain why here in a second. You'll notice that the very first invoice in here is for vendor ID 34. So when I'm sorting by vendor ID, so there is no invoice for vendors 1 through 33. The first vendor who has invoices is vendor 34. So let's go back here, and you'll see that why do we see vendors without invoices? Well, that's because none of these are all the vendors on the left side on the vendor table, but none of them have sent us an invoice. And now the very first one that has sent us an invoice is IBM, that's vendor 34, and they have 2 matching records, that's why we're seeing it twice. So the left join is, again, it's telling us when we run these queries, give me everything on the vendor side that matches to the right side, and plus give me everything on the vendor, give me everything on the left side that doesn't match. And that's what we're doing there. So in this scenario, this is just showing you that we can not only left join one table, we can left join multiple tables. Actually, no, this is still joining just 2 tables. The reason I'm a little confused here is that this code is not pretty and formatted. And so again, always write your SQL in a nice, clear format. So yeah, this is just doing another left join. It's saying, give me all the departments, regardless if there's an employee on this other side. And we should be familiar now with this data. We could see, hey, there are 5 departments, departments 1, 2, 3, 4, 5. But the operations department, what this is saying is that there is no person tied to the operations department. And if you don't believe that, or you're not sure, go look at the data under the underlying tables, and you'll see why that is. If I do this same exact thing, so this is the same query, but it's just changing it to a right join, you'll see here that here are, all the employees. There are actually 9 employees, and you can go look at the data to confirm that. And we'll see that these are all of the departments they are assigned to. But Watson and Lucario, what this is saying is that, hey, they are assigned to a department that doesn't exist. And if we want to verify that, we could say, hey, let's go select star from departments. And yep, there's no department 6. So that's why we don't see them. Now, again, remember that we don't need to use right joins. What we would normally do here is just trade these out. We would just say, let's write them as a left join. So I'm going to left join this guy. I'm going to go join it to employees. And I'm going to just steal from this query. So this is the exact same as doing a right join. And, a fun way not to jump too far ahead. You know how I could know that they return the exact same thing? I'll show you. Let's do this. Let's do a right join. So we're going to go to departments D. And this is honestly the best way to become really good at SQL is just start playing with it. So notice here, if I do a right join between departments and employees, it's going to give me every employee regardless if they're assigned to a department, right? All right, so that's the result we get. I just showed you that I could flip the order of these tables, and I could say, give me everything from employees on the left side, regardless if there's a department. So it's the exact same thing. It's a left join, and that works just fine. So one way that we could actually test this out is, let's just see. Let's jump a little ahead really quickly to that minus statement. So let's go minus the results of this table from this, and let's see what we get back. If they are the same, we'll actually get back nothing. Oh, wow, there we go, nothing. You're a geek if you're like, oh yeah, that's pretty cool. But if you're like, whatever, then you're just not a geek. And I'm obviously a geek because I love the minus statement. It's really valuable because now I know that the results of this query, when I subtract them from this, if I get nothing, I know that they're logically doing the exact same thing. So there you go, just showing you that. So then the full outer join, what that will do is it's going to turn everything from the left side, so all 5 departments. It's going to show me all the ones that intersect with the right side, the employee table. And then it's going to show me all the stuff on the right side that doesn't intersect, and all the stuff on the left side that doesn't intersect, and all the stuff on the right side that doesn't intersect. So what full outer is doing is, both parts of that Venn diagram. The left side, the right side, and the stuff that intersects. So when you do join multiple tables together, the reason why we want to stick with just doing left joins is that if I were to left join departments to employees, first thing, it's going to do this join, and it's going to give me back a data set. And then it's going to then treat this data set as its own kind of separate table that then gets joined to this. So if you'll think of this as now departments left joined to employees as its own little table, and then now you can join that to another table. And to do that, you simply just say, as soon as you've done this join, this table to this table on these columns, and now all you have to do the next thing is just no comma, no nothing, just say left join to projects on employees ID, so that's the thing that the employee table has in common with the projects table. So when you run this, what we see happening here is that this is every department on the left side, regardless, every department on the left side that regardless if they have an employee or not. And so that's what this that first left join does. But then what it's doing is it's left joining to the projects table, and it's saying that means give me everything that's in this first result, regardless if there is a project on this side. And so that's what this is showing you, is that operations has nobody assigned to them, so therefore they have no project assigned to people because there's no people in there. This one has Hardy assigned to maintenance, but Hardy has no projects assigned. So it's saying everything in this original result. And if you wanted to, we could actually, I could chop that out. I could chop out this. I could chop out this and just show you, just do a basic left join. And you'll see here's the results. If I go back and I put in now this left join to projects, you'll see that it's still the same results, but now it's just left joining in the project. So, and if you are going to do a full outer join of multiple tables, the same rules apply. Right? If you do this full outer join, it's going to full outer join the department's employees first, and then it's going to then do that join here to the projects. So that's the result you're going to see here. And if you go and if you're confused by this, again, just try to look through, try chopping out parts of it and simplifying the query, and then build it up as you go. So run maybe a simpler part of that, look at the results like I just did on this previous one, and then add in layers of complexity and see if that makes sense. And yes, you can go and combine inners and outer joins. So in this scenario, you could do where we're going to do an inner join of departments and employees, and then it's going to left join that result to projects. And when we run this, what you'll notice is that operations isn't here. And that's because when we run the inner join, operations doesn't actually have an employee assigned. So therefore, that example doesn't show up. So now we're left joining that result to projects. So it's going to show all of the departments that have employees, regardless of whether or not there's a project assigned to that employee. Let's jump into union statement really quickly, just to kind of briefly describe what we're doing there. So when I explain union statements, what I typically like to do is I typically like to kind of, cut it in half, and I like to just focus on the first query. And so when I run this query, if you look at it, you'll see that it is using this explicit string. So what that means is that I want to hard code my own value for every row here. So you'll notice that the word active with a column alias of source is showing up. And the reason we are putting the word active here is that this is describing, so notice it's actually pulling from a table called active invoices. And this is all the invoices that met a certain rule as being active. But what we're doing here is we're pulling from this table, active, and so if we go through here and we run this query, it's going to return 12 rows. I can also run this other query. I'm going to just run just these 3 lines, and we're going to see that we get 10 rows back. It's all of these marked as paid. So maybe what I want to do is I want to have kind of 2 different sets of data. So I want to have a query that has my paid invoices and my active invoices. And from there, I want to, not just have 2 different, grids of data. I want to kind of stack them up. and pull them all together. It's going to be very common, right? If you think about, like, I want to pull a report that has, the same, it's all about customers, but maybe I want to know, like, here are all my customers that are ordering and all my customers that aren't ordering, right? And so taking kind of two different versions of a query about the same data and stacking on top of each other. So now if I go back and I look at these two sets of data, what I'm going to do is, you'll notice that they all have 4 columns, or both of these queries have 4 columns. One is the source, the invoice number, the invoice date, the invoice total. So I'm just going to basically say union these two queries together. And notice that there's no semicolon right here, right? That will cause this to mess up, because when you run that semicolon there, it does terminate that SQL statement. It's not going to run. So you have to run them without, if you are going to put a semicolon in it, you put it in here at the very, very, very end. If we run this, now we have the 12 plus the other 10, and here they are, right? Here's active, here's paid. And now that we have access to this, we can even add in an order by at the very end. You cannot add order by here, and you're not going to be able to sort the first set, and you have to. This is now all one data set, so you have to still put the union at or the order at the very end. And sure enough, what it's doing is it's ordering by invoice total, but we could order by source if we wanted, right? We can order by source and invoice total. And we could even do it like order by invoice total descending. So sure enough, here's all of the actives, because that's A, and it's all the big ones first. And then it goes to P, all the big ones first. And that's what the union does. This was another example I think I showed you in the pre-lecture, but it's just doing, it's instead of grabbing from different tables, this data is just pulling everything from one single table that meets, the invoice balance does not, there's still a balance on this invoice, so it's still active. And this is where the balance is now 0. And so it's just showing you the exact same logic. So I'm not going to run that. In this example, you'll see here that we can go and grab, data from multiple tables. So we can do a join, and we can actually, again, we don't always have to put these explicit strings in, but these kind of make sense. Like in this scenario, we want to pull the invoice number, the vendor name, and we want to say, there's this payment type. And then they actually have this is actually kind of a complex query. So if we just run this by itself, you'll see here that it says 33% as the payment type. There's the invoice total as total. And then what this is taking is the invoice total times 0.333. And this is actually the payment that they are supposed to make a payment on. So this is a 33% payment. So it looks like based on if the invoice total is greater, they're supposed to make a 33% payment. All right, so let's just look at that and run that. That's what we're getting back. This next query, what it's doing is if the invoice total is between 500 and 10,000, they're going to require them to make a bigger payment, it looks like. So there's a 50% payment, and it calculates the payment out. So this is a really great query because it's showing you explicit strings. It's showing you how to use some arithmetic expressions using the where clause. We're joining multiple tables together. So let's just look at what happens when we run just that. Sure enough, this is what we're getting back. So let's just run this guy. Let's just see what happens. Let's run this whole thing. And notice I didn't have a semicolon at the end of these. I have it at the very end, so that's why I can just run this whole thing, and it's going to start at the first, and it's going to run the whole thing. And yeah, as we go through this, now we have all of our data. So we're pulling kind of we're pulling like a chunk of the invoice data and a chunk of it, different chunks of it that meet certain rules based on this where clause, but and this is a much more descriptive report. Now we can actually go in here and say, okay, well, these are all the ones that need to make full payments, so this is the total and the payment they need to make. Here are these ones that, are between 500 and 10,000. They need to make a 50% payment, so that's what this calculation is coming out to is their payment. This is 33% payment for the ones that are over 10,000. And so we've unioned 3 queries together. And it's really simple. That's all you can do. You can also say union all. It's not required. But if you do that, it will do the exact same thing. And so the minus statement, as we've shown you in the kind of pre-lecture, what this is doing is it's taking a set of data. So very similar to the union, it has to be the same format, it has to be the same number of columns. Doesn't have to be the same column names, but it does have to be the same data types and the same number of columns. So notice these are both text and they are both 2 columns. So in this scenario, we have customers on the EX table, we have names on the employee table. So what this is doing is saying, hey, give me a list of all of my customers that are not sharing the same name as an employee. And so you'll notice, that Tom Hardy is here, and I think Tom Hardy, and you may not notice this. I just know this because I've played with this data enough that, let's see here. Tom Hardy is here. So what this is simply going to do is if I run this, this is the data set this is all of the customers on the customer EX table that do not intersect with the employee table. And the way for you to simply just check, well, how do I know which ones don't show up, is we could do this, right? We could just say which ones intersect. So intersect. If I run that, this actually is saying, hey, all the ones that are in both of these sets of data, show me them. And sure enough, here's Thomas Hardy, right? He's in both. The example that I want you to go play with in the practice is I want you to go and write a select that pulls all the vendors from the vendor ID and then a distinct list of vendors from the invoice table. And what you'll find here is that this is giving us back this list of data. But you'll notice that as we progress through here, right, the first one I notice is that vendor 34 doesn't show up in here. And I want you to figure out why that is. Why is it that I have a list of all my vendor IDs on one table? When I subtract the list of all the vendors that are on the invoice table, when I say, okay, if you have a vendor on the invoice table, go remove that from this list, what is left? What are those vendors? Vendors that don't actually have invoices, all right? That's kind of the answer, but I want you to think through that. Why does that make sense? And what are we getting out of that? And so I've shown you here to you can just swap, just like you can kind of swap inner join and left join out, you can swap out union and intersect easily. So try doing both and practicing those. But that is it. That is the last bit of content on joining multiple tables, talking about the outers and the inners, and also just covering unions and intersect and minus. And by the way, I want to point out one thing. The minus statement is something that exists purely in Oracle. So SQL is a ANSI language. It's a standardized language. So when you write select star from table in MySQL or Postgres or Oracle or SQL Server or whatever, DB2, that statement will run across all of those. It's a standard language. But there are some additional things that Oracle and SQL Server will throw in. And so Oracle uses this thing called the minus statement, and it does not exist. If you want to do a minus statement equivalent in SQL Server, you'll go out and Google and say, how do I do a minus statement? And then Google will quickly tell you in SQL Server. And that's a common question. And so people are used to using these things like the minus statement. It'll point you back to resources, and Microsoft will tell you, oh, well, you can just do this with a left join. If you just want to pull back all the customers in this one table data set that don't exist over here, just use an outer join. And so if you get good with outer joins, I would say do that. I got very heavily involved in using the minus statement. I was very weak on using the left joins. So I think it's good to know both. But also just note there are some reserved words and functionality in Oracle that you won't see in other SQL developer tools. And that's okay. You'll just have to kind of learn to remember, how do I do this in this other tool? And there's a lot of great things online that'll help you. So I'll stop there. I hope that was helpful. If there's any questions you have, go try the practice. Maybe that will help you as well. But this will get you all ready for the assignment that's coming up, where you're going to have to write some pretty complex queries using both inner and the outer joins. So until next time, we'll see you in the next lesson, and thanks for joining.